x, pt, or ft, among others, their notification. But what we need to know is x variable, pt variable, and t variable. These keep changing, and there are the values that from the domain that impacts change, okay, of the function. Instead, we have different functions types, including rational functions, onto functions, into functions, one-to-one, many-to-many, many-to-one, identity. Yeah, all those are different types of functions. We need to know that. Now, to study the rate of change of quantities, okay, then f prime of x is equivalent to n x n minus 1, meaning we get the same value of x. We get the power, get the power and multiply it by x, then you reduce the power by 1. This is the power rule. And we said an example, if this one was executed, then you would get the derivative by just saying take out the power and then reduce the power by 1. That is important. Okay. Now, those are so far 2 rules. We also have other rules. Number 3. This is the constant multiple rule, where we say that if of x is ch of x, we don't care. F prime x will be c h prime x, meaning that the constant doesn't have any impact. The constant, yes, please.
I think you're moving a bit faster. Can you please reduce your speed so that I can catch up? You are moving at a terrible speed. So try to move slowly so that I can see what you're doing very well.
Yeah, maybe because I'm doing a revision. This is revision, so I think the speed is okay. It is not a new concept. I'm just reviewing what we started yesterday.
The speed is fine, sir.
Yeah, it is revision. I already taught it this
You've
one.
You've already gone through this, so you just reviewing.
I'm just reviewing. Yes.
And
So
okay. Thank you.
We said we have the sum rule, and we said if you have functions and you're adding them up like this, then the derivative is basically the sum of the of the individual functions. Number 5, as we conclude, we had the difference rule. The difference rule, we basically change this one to apply to a minus. Now, I will slow a bit down here when talking about the different, the advanced rules, because I know I think it's responding. So ideally, the reason why I'm reviewing it is so that people can make them part of their part of what they know, because there is no way you're going to learn differentiation minus knowing these rules. Actually, like realize as I start talking about other functions, they are still the same rules. Okay. So we also talked about advanced rules. Number 6, we talked about the product rule. Product rule, basically, the word product means multiplication. Okay. If you're multiplying the two functions, for example, if f of x equals to dx, hx, this is a product of two functions. For example, fx equals x squared into x cubed minus 3x. This is function 1 and this is function 2. So we are multiplying two functions. We must apply the product rule, which says that we shall get f prime from the first function times the second function plus derivative of the second function times the first function. So just to observe the pattern and actually be able to apply these principles. Okay, so when you look at that example, here I'm going to look at one example under each rule. Okay, these are two functions. This can be function 1, this can be function 1, and this one can be function 2. Okay, and if we want f prime x, you see, we say to get the derivative of this first function, which is 2x times the second function, plus derivative of the second function, which is going to be 3x squared minus 3. You see that? Times the first function, which is x squared. It is important that you write your answer in the very simplest form. Okay? Multiply out the brackets, correct like terms until when we come up with the most simplified answer. Then finally, as I end the review of the quotient rule, and we say that quotient, first of all, means division. For those who didn't know, says that if I have a function, say h of x over d of x, this is a quotient of two functions. We are dividing function 1 and function 2. A good example can be if you were given f of x to be equivalent to functions like x squared over 3x cubed minus 2x. This is a quotient. We are dividing two functions, okay? And to do that, we always apply this. Get the derivative of the first function times the second function minus get the derivative of the second function times the first function all over divided by the second one squared. Okay, so taking this as an example, if we take this one to be 1 and take this one to be 2, okay, you will realize that if I'm interested in finding the fx, it is going to be the derivative of the first function, which is 2x into the second function minus derivative of the second function, which is going to be 9x squared minus 2 into x squared all over the second function squared. Okay, substitution here is not enough. It is important that we go ahead and simplify the numerator, especially its simplest form. Okay, that is the quotient rule. Let's make sure that we really understand the quotient rule, because if we don't do that, we are going to find other things still a little bit complicated. Okay, are we together? Any question there? Yes, please.
I would love if you're completing the review, at least you do one of the numbers to confirm if you don't mind, sir.
Which number?
This one, 1, 2, 3, the one of fx 8x, 8x, the one of 8x. I think it's 5. 1, 2, 3, 4, 5. Yeah. You get it, Mrs. Mayor. I think it's number 5, if I count well. 1, 2, 3, 4, 5. The one of xx 8x to power 4 plus 9x squared minus 1.
Which answer did you get?
Actually, I failed to come up with the answer.
I want you to know what you get, what you got.
Like
I will not.
I couldn't come up. I couldn't come up with the answer. I just, I left it hanging.
This one.
That one.
You mind. This one that requires directly whatever. You failed it, and you did try. Okay, which one did you do? Which one did you attempt?
I did number 1 and the.
What did you get for number 1?
For number 1. Number 1, it was. Let me check here. Number 1, it was. If we substituted in the first row, because I substituted in the first row, so I got 3x minus 7 out of 4.
What do you call your number 1? Are you seeing my screen?
My number 1 was x to the power 7 plus 10. X power 7 x to power 7 plus 10.
So this one, f of x equals to x power 7 plus 10. What was your answer?
3x minus 7 out of 4.
How did you get that answer?
So I don't know how I can explain, because I'm using a phone. That's the problem. And I calculated using a book. Like I did handwritten calculation.
And you tell us that I did this and this and this, because I'm just wondering what the answer. 3x minus 7 over 10.
So if you wonder, meaning my answer is wrong, right?
That's why you want to understand how you got it. You tell us that I did this and this. Let me see something here. It's texting something. I got this answer and I can explain. How you got x plus 2 plus 10?
I substituted.
Kasiriye Brian. Fx equals x squared plus 10. Okay, I don't know where you got that question anyway. You substituted.
The first rule of 12. Could you please roll up this? Let me see. There is a slide you are listing up this the rule.
Hey, Chief, you have a lot of problems. If you're just cramming the things, that's how you're going to fail mathematics. It is important that you understand the principles, not cram work.
Okay.
If you cram, mathematics is not for cramming, it is for understanding. One of the rules is the power rule, and we said f of x, if f of x is xn, is x power n, then the derivative is n xn minus 1. And when you look at the problem you're looking at, it is straightforward. You don't even need to stress yourself. Apply the power rule and get f prime x equals to 7x power 6. Now, I don't know what substitution is used, and we substituted in. Apply principles basically the way they are, not just substituting. So the answer I expected is 7x power 6. Even the reason I asked you about your answer is so different. It is very, very far from the correct one, you know. And I'm wondering how the fractions came about. And the same approach follows for number 1. The same approach follows for number 2, for number 3, for number 4.
So, sir, if I could ask a question, how do you understand that this question needs to be substituted or one of the other rules? Like, how do you? I don't know if I can explain it. Like, take an example, number 6. Okay, number 7. How do you understand that this number needs power rule, or it needs? How do you quickly like interpret that? Because I know if I'm wrong, then I think some of us are wrong, because it's not me alone, and one of us could have used, or like, take an example like me, I used the other rule, not power rule. Now if I use power rule, meaning I have to get a wrong answer. So how do I interpret the number that this one needs power rule, this one doesn't need power rule? Just like that.
I think, Chief, did you attend yesterday's class?
Yes, I did, sir.
I think you might need to first review what we studied yesterday very well. Because your question wants to take me back from where I started, which I'm not going to do. Be very sincere.
Okay, sir. It's okay.
Yes, I'm not going to do that. The rules are very clear. I really don't know how to explain them now. The rules are very clear that when you're differentiating a constant, you get a 0. I had over 3 examples yesterday about that. I don't think maybe it needs someone to explain in another language that if you're differentiating such a function that is constant, you get a 0. But there is nothing I can add. The power rule, when a variable is raised to a power, you use the power rule. The constant multiple rule, the sum rule, if you're adding up things, like in that, it was x power 7 plus 10. When you're differentiating this one, you differentiate part by part. Part by part. The first part applies the power rule because it is x raised to the power of some value. Then the next one is a constant, which is going to be a 0, eventually coming up with f of x equals to 7x6. When do you apply the difference rule? Difference between the two. When you have a difference between the two functions. When do we use a product rule? It is very clear, it is here. Even in my review, it is very clear. We have two functions multiplying themselves. This is x squared, function 1. This is x power 3 minus 3x, function 2. I really don't know how much I can add to this. And the quotient rule, I'm making it very clear. Whenever you have a division of two functions, even this example is clear here. Okay, let me talk about the composite function rule. Whoever is still confused, please make time and review. Make time to try to understand the concepts. I'm proceeding with what I wanted to share today. So, as we discuss about functions, sometimes we have a function in a function. I'm just building a case, and later on, I'll okay. Is my screen visible or something has happened to it? Are you able to see my screen?
I can still see it.
Okay, thank you. Now, consider this example. If we have a function, say x squared minus 2, the whole thing raised to the power of 10 equals, say, y. You see that? When you have such a function, we are having a function into a function. Okay? If you let u to be x2 minus 2, this one is also a function on its own. That means that my y is going to become u power 10. Okay? If I substitute for u. So, all functions raised to the power of a positive integer represent a function in a function. Represent a function in a function. And the way we handle such is slightly different. Leave along this. If I have x squared, you don't say this one is a function in a function. But if I have x cubed minus 3x plus 2, this one is a function in a function. Okay? And such functions show we have y, and y is a function of u, whereas u is a function of x. Okay? Y, it is here. Y is becoming a function of u, and u is a function of x. So the way these are related, to find the differential calculus, we use what we call the chain rule or the composite function rule. We use the chain rule or the composite function rule. According to the chain rule, if y is a function of u and x is a function, and u is a function of x, then dy, not this, then dy dx equals to dy du times du dx. This is the generic representation of the chain rule. Okay, and it appears as if this one cancels with this one, remaining with the divide here. Now, when do we apply this composite function rule? Sorry, yes, it is called a composite function rule. Composite function rule, or it is called the chain, or it is called the chain rule. When do we use it? One, you must make sure that a function, say y, is in the form of a function, say x squared minus 4x power to the raised to the power of n. This one means that we can let u to be a function of this sort, and y can be a function of u power 10. So we are expressing y in terms of u and expressing u in terms of x. Okay, we are going to see some examples, actually starting with that one. Appreciate the chain rule, and in the write up you will see what will show us what will be a guiding principle for us to appreciate and use the chain rule. When you look at this, if y equals to x squared minus 2x power 10, like I mentioned earlier, this is the function. In the function, and whatever I always need to do is to let u be x squared minus 2x, such that my y becomes u power 10 if I substitute. Okay, if you substitute y here, if we substitute for y there, we get this. Does that make sense?
Yes, sir.
Yes. Now, according to the chain rule, or even before we get there, from here, since what u, okay, we realize that u is in terms of x, okay, meaning we can get the u, the x. Okay, here y is in terms of u, meaning we can get the y, the u. Okay, we can apply the common rules as we know them to get to x minus 2. Correct? Also here, we can get n u power 9. We can get n. Someone is saying, cannot see my screen. That one might be an issue on your end. Can you try to double check that?
Excuse me, sir.
Yes.
Like I'm asking on this chain rule. Like if the function is a fraction, how do you go about it? If the function is a fraction, like
Give an example.
like if you still use like if you said if y is x squared minus 2x to power 10, take an example out of like 2x.
Okay, good. If, for example, y equals to x minus 2x power 10
as a function, then 10 to power 10 out of 2x.
The whole thing out of 2x.
Yes. Or 2x to power 7. Okay.
Whatever. You can put even power 3.
Yeah.
Now, one, we are seeing the chain rule for the numerator. And we have, after getting that, we have to also apply the quotient rule. So here, we expect to apply 2 rules. The main rule is the quotient rule.
Yes.
Then after applying the quotient rule, remember at some point you will need the derivative of the numerator. Correct?
Yes.
at that point of needing the derivative of the numerator, you must apply the chain rule. You must go through what I'm doing now.
Yeah.
Okay.
So, sir, can you please apply? See what we get.
Let's first complete this. So here, we know our dy dx is going to be dy du times du dx, which will give me dy du is 10 u power 9 times du dx, which is 2x minus 2. And eventually, when we substitute for u, we shall get 10. We shall get 10 in brackets x squared minus 2x power 9 times bracket 2x minus 2. Y has been what? Y has been x squared minus 2x. This one raised to the power of 10. And we are saying that after doing the answer, we are getting dy dx equaling to 10 in brackets, equaling to 10 in brackets x minus 2x 9 x squared minus 2x power 9 times bracket 2x minus 2. That is the answer we have got. Okay. Now we want to go to this case. So, is this example clear up to where we have so far reached? Okay. Silence will mean yes.
No, sir. Maybe
Now,
repeat.
looking at this case, let's create a case here. If y is equivalent to x squared minus 2x over power 10 divided by, say, what was his case? 2x cubed.
2x cubed.
Let me see. Oh, sorry, yes, divided by 2x cubed, and you require to find dy dx. Here, it is a quotient, you must use chain rule. Which chain rule says that dy dx here is going to be equivalent derivative of the first expression, right? Whose derivative is here? We have already got. If you had not got it, you should have gone through the same process.
Same process, yeah.
And come up and get 10 x squared minus 2x power 9 dot 2x minus 2. The whole thing times the lower function, which is 2x cubed, minus the derivative of the second function, which is 6x squared, times the first function, which is x squared minus 2x raised to the power of 10. The whole thing divided by the square of the second function. So, simplifying this one, if it can be simplified any further, will actually lead to the final answer needed. If it cannot simplify, like I see, you can leave it like that. It will be the correct answer. But just know, if we had not found, if we had not already checked out the derivative of the numerator, it will be still part of the process for getting this answer. So that's how we apply these principles step by step.
Mr. Chimera,
Yes, please.
I want to tell you that too.
I'm listening, but you are very far from your microphone, I think.
I'm saying
Yes.
I'm trying to following you, but things are still hard. I don't know whether we still need time to practice this. I don't know for sure.
So, what do you want me to do, sir? Because I'm trying to teach from the very, very first principles. I'm trying to. Yes, please. Change the. Are you doing it?
For me, I don't understand. Is it me only or the class that are all still confused? Because I want to hear the response from others, but I don't know whether for them they are getting each and everything you are telling us, or whoever gets anything like picking up something, at least should come up and tell us what should be done. Oh, it's me who is still behind. Thank you.
So actually, me also, I think I kind of messed up on the question. Yeah, the question rule. Then the chain. Now it's totally out. I don't even know. Anyway, it was a network problem. So now I'm coming here and I don't know anything. Yeah, I don't know if you can enlighten more on that.
Excuse me, Mr. Lecturer. Hello? Don't-
By asking, is this clear? And everyone keeps quiet. I will have no option apart from going forward. Some people, I think, attend
Mr.
class with aided mind. That is also another point.
Mr. Chairman, excuse
Yes.
me, sir.
I'm
My
listening.
name is my name is Kaibala Edward.
Yes, sir.
So some members of mine, I mean fellow classmates, really they are finding a big challenge with the mathematics. The difference we have here,
Yes.
some of us have ever seen, according to the level we are, some of us have ever seen, some have never. So that's what I can say, that we can't be the same. 'Cause some have ever seen and some are understanding. Others totally, I don't know. They might have not seen. But with mathematics, you can't scoop things at the first time. It's a bit hard. So my view is maybe we try to mobilize ourselves, come up with consolidative discussions, so that there is time to absorb things. Otherwise, question, they can't absorb everything as per now, because principles are, it's a new language to them. That's what I can say. Yeah.
And that is correct. And they have not put in any effort to try out exercises.
Yes, it will need actually effort.
You get my point. The
Mm.
reason I included very many exercises here is for people to try. But even when I asked, people have not done these exercises. Yet in such a class, I would expect people to say, let's go through the numbers. For me, for number one, I got this. For me, I got this. For me, I got this. You know, if 4 people have got different answers, then you will repeat it here and do what? And do the answer. And do the question together. But someone wants me to do the question minus him just trying out. I'm not going to do that. I want to be very sincere. I want to repeat a question when someone has tried, even another person has tried, you know, when I'm there too. But to be very sincere, how many people have done these questions? Have tried out? How many?
Mr. Chimera, for me, I tried number 2 and number 3 and number 1. I'm
Now,
Emmanuel Mayanja.
This is what I told you. You see the practice questions I'm pointing that now?
Yes, sir.
Yes,
I want all of those questions done. You know, check. Let me take you back to my very first notes. Let me skip this. I really try to understand what you're saying. Check how my notes are structured. When I talk about the constant rule here, are you seeing my screen?
Yes,
when
please.
I talk about the constant rule here, I have 2 examples. When I talk about the power rule, it is well explained. There are examples here. There is another example here. There is another example here. Same thing. People have not done this. Now, how do you expect me?
Sir, for me, I also tried that try question.
Someone
Excuse me,
confused about the power rule. The same
excuse me,
thing
sir.
here. Yes.
Yeah, my name is Omar Soboga.
Yes.
I've not had a chance to speak since this class started. However, I'd like to agree with Edward, who has previously spoken, that there are people who at least did the mathematics at A level, okay? And there are some of us who have not done mathematics at A level, okay?
Yes.
So the level at which we absorb new things is different. However, we're not saying that we're not putting any effort to revise. But remember, some of us are working class. So yesterday we left the class late and we did not make time to revise because already this is the only time we have. So our request would be, because we normally form discussion groups, which we only meet over the weekend. You get it? So my request would be at least let's have a meetup over the weekend so that we go through these questions. But it was so difficult for us to make time to go through these questions because even our colleagues who help us were not available since yesterday. Thank you.
Now let's do this. Thank you very much for that submission. Now, whatever I told yesterday, you know, when you're climbing a ladder from level 1, you go to level 2, you go to level 3. It does not make sense for me to go to level 9 when people are still on level 1 struggle. This is my suggestion. You guys try to go through my notes from where I started from. Do these basic examples. I organize the notes to the extent that even someone who has attended the class but has not studied mathematics has enough examples to try. Then our next class I will review. It must be interactive. I hope it is even going to be physical. I will review all of these rules. We shall look at all of these exercises. And the trial question is in here. But I will have to first see, like, people will be first showing us the answers they have got. Okay? Because for sure, there is no way you're going to tell me that you do for us this question 7, for example. When no one has something, that is not going to happen. So, what we are resolving, actually, I earlier told you that the class will be a bit brief. I have a presentation to make here on the next 15 minutes. Let's agree. Let's try to check through. Okay? I will review all of the concepts and make sure every person understands if people show interest and show seriousness. Okay, that's what I promise. So make something, go through the notes.
Mr. Chimera, I beg to submit something.
Submit.
I'm Emmanuel Mayanja. I do accept the fact that I also have at least some information on mathematics, that is O level, but I've tried to follow your notes. And yesterday I was totally green for sure. But today when I gave it a try, I've understood the constant rule, and I've also understood I've understood the power rule. And I've noticed that the more you go further, like the more you advance teaching us as we grasp slowly, it makes us get complicated somehow, somewhere. But at least you've stretched it very clear that you will give us a recap and look on what we get. I think that will make us know where we make mistakes and we grasp these rules. There are quite many rules and we can't grasp them at once. But we appreciate that you give us a try. Thank you, sir.
Thank you. And remember, we are still working with these basic functions. We are going to trigonometric functions and we are going to exponential and logarithmic, applying both the differential and the integrals.
Mr. Chimera, I beg to submit.
Submit.
Yeah, my name is Brian. Well, I tried to attempt some of the numbers, but I just need to understand at what point does a number apply to more than one functions. Like question 1, when I identified the function, I came to find out that I can apply the sum rule and the power rule.
Correct.
Yes.
Because there is this plus. Because there is this plus.
I can also submit the
sum rule. Good.
So when I'm giving a solution, when I'm solving that number, do I solve it with all the 3 different solutions, or I can all the 3 different rules, or I can stop on one rule and then I submit and stop there and get the marks?
Provided you get the correct answer. It is not about applying the rule as in applying them directly, but it is about knowing them. That here, if I'm differentiating x power 7, power rule. If I'm differentiating 10, it is a constant rule. Then there is a plus. Sum, I have to combine the 2.
Yeah. So, Mr. Chimera, finally, my submission on that, I would love, in my opinion, to help some other people who have never done mathematics. When we are giving solutions, we apply the things they look at, like where you can say, maybe if you're applying the sum rule, you can split the recipe into like maybe 2 parts, and you say like flour and sugar, and then you give explanations around that. Maybe they can be able to pick something. I don't know.
This is interesting.
Yeah.
Okay. Let me give you the weekend. Let me give you the weekend to review. Let me also think through how best we can make our colleagues pick up the pace.
Mr. Chimera.
Yes, please.
Shaban has raised his hand. I think you should give him a chance to talk about something.
Please, you tell us.
Yes, Mr. Chimera.
Sorry, my submission is there are some other people what their classes this time. So they go to when you finalize. I'm one of them. So I'm just suggesting
Oh, you're not
Mr.
clear.
Leader,
Your
your
network is
network is poor.
overdropping.
We can't get you.
okay, let me pass it. Question.
Now, what I was trying to say, Mr. Kime, right? Hello?
Yes. Yes, please.
I was trying to say,
Mm.
no?
Oh, talk lecturer is really waiting for you.
Now, Mr. Kime, I'm back. I'm sorry.
Yes, please. Mm. Please come back and tell us.
Okay.
Shaban, he talk to
Now,
the lecturer is waiting for you.
what I was trying to say, Mr. Kime, I was just suggesting you started a
Yes.
class when some of us we had poor network and we were not able to do what to pick up what you were teaching at the beginning. So I'm just suggesting, if possible, please can you share with us these notes which you have taught today? At least we also start from there. Thank you. That's my suggestion.
Yesterday I shared the notes with the organized write-up on your WhatsApp group.
But he shares the notes every day, every lecture. No,
I hope you guys.
I'm trying to mean this one in a way to what? This one which you're trying to go through. The one
Where I write. Yes, I have been sharing.
Okay, thank you, sir.
This one today I'm not going to share. It is not very organized. But yesterday I shared organized.
No way, sir.
And,
Like,
and
seriously?
again, hello. And again, what I'm seeing happening, Mister, how do you say like every day you leave us with maybe 1 or 2 questions we go through, we try them by ourselves, then we discuss them after. We discuss them as a group, then after we submit it to you.
I think that's what I've done. I gave you guys many questions. And today when I came, I said, with this question, any issues? No question. Otherwise, we are going to review all of them. I'm actually not what you guys are doing.
Okay, then that's good. Okay.
No, I'm thinking very well of your comments. And
I think Mr. Remy just wish you a nice weekend. Thank you for what you've done for us today.
Yeah, thank you very much. But let's see.
As I wish even our class president. That's none other than Anafat.
Let's agree this, guys, before you drop off. Let's agree this. Okay?
Yes, please.
Make sure you read through these things. When we meet up next time, I'll try to review everything. But all questions in there, I'll be requesting if you people give me answers you have. For
Now
any
again,
question,
my
question where
suggestion.
you don't have something, I will not do it.
Okay, Mister. Again, what I'm trying to say, like me, how do you say, like if you organize like a group of five or three people, three members or 5 members, we'll be trying. Then after, because I'm thinking that's how we are going to do to manage to catch up with this mathematics. Because there's some other guys who are not good in it. Then if we do that, I think
you need a group someone to give other assignments and courseworks that are group related. So you also need
leave alone coursework and coursework. Just the trials, you just give us trials, we do them as a group. Then after we submit it together, like after lectures, we submit, or maybe on the day of what? Like a discussion.
Mr. Rogers. My suggestion is, at this time around, you don't need to like doing exercise. You need to like groups to discuss this mathematics. This mathematics is taking away, it's taking that
correct. Correct. If you leave us with some like assignments,
groups. Yes.
yes.
But when you give an assignment, no one will answer any question because we don't know what to answer exactly. We still need time to submit to make sure we catch up with everything.
Omusajja yeekubidde
Even if it is a coursework tomorrow, no one will submit the correct answers.
For me, I will submit.
I'm on.
For me, I will submit.
It's you will not submit.
It is you, Mr. Ambody, but some of us will shall submit. No, that guy is creating a path to himself. What he's trying to say, Wambi, is very correct.
Yeah, I'm getting the
We have to
truth.
do an organized group whereby we are maybe we can do it.
Mr. Chimera,
Let's do this.
I beg to comment, but before I comment, I would like to know what time are you ending this lecture before I make my comment, sir? Since you said you're going to go early.
Yeah, I want to drop off and prepare my things here for the presentation.
At what time, sir?
In the next few minutes.
Okay. Now I beg to put a comment, sir. Since we are given a chance to stay online on the V class for the rest of the time, I've realized that when you get off, some guys just stay on for the sake of finishing the time. So may I make a comment right now before before guys also get off? Like I would like if someone has grasped at least the basics. For example, the constant rule, the power rule, some of the simpler ones before we go into the complicated one. At least he should pledge that if the lecturer goes away, I can take the guys back to what I've understood. At least that would make some of us to pick something before we wait for the lecturer to come maybe next week or for a general discussion. So I beg at least, sir, before you get off, we get a volunteer. He agrees to carry us on as soon as you break off. Otherwise, when you break off, all guys will just, especially those who have grasped the idea, they will just stay on however much you call, please, guys, Brian, come and help us here. They will just keep quiet until everyone starts to disappear. Please, my humble request.
No, with that,
I'm asking to also raise.
Emmanuel,
that's not bad, but it is also not a man. We have to just organize it by also. If Mr. Kimera doing his work, the remaining part is our work for him again to come and organize that.
I don't know who to respond to. Everyone is calling me.
Yes,
no, that's what you're talking about.
Emmanuel, I'm saying something.
Go ahead, sir.
Emmanuel, mathematics is too practical. And grasping those concepts needs at least to be jotting down. For example, the way Mr. Chimera expresses is, yes, sir.
Please, we can catch up later. I need to.
Okay, sir. So I'm saying, yeah, Emmanuel, I'm saying mathematics is too practical. And to grasp, there is no, we don't have our gadgets are not to that level that we can write, to write and express the principle. You understand? For example, if you say that the concept say, subtract 1 from the power and then put the power down and maintain it, there is no way. When I say it by mouth, you will not understand it. That's why yesterday we are struggling to find a sophisticated board so that we can express for those online. So what we have to do is to try our best to achieve what we discussed about yesterday. For here, we are going to use words and we will not pick anything. Maybe we discuss how you can grasp mathematics. It is
That's what time are we linking up tomorrow?
Okay, thank you, Edward.
Discussion.
Now, Emmanuel, for me, what I'm saying, actually, what you say that we have to stay on what while being devising. Yes, it's also not bad, but actually, too much of everything is also what it. You know.
we have to revise, but not that we have to be there all the time. Let if someone has understood something, let him go with that. Not again to overload him again, and then he forget what he started with. You see?
By the way, guys, to be open enough, if you don't grasp these things at the first, when you reach exponential, things will be tough.
Yeah, that's why I'm saying that it is better someone to understand the
Things are
first
going to
work
become
before.
bigger.
Okay, Edward, thank you. And Musaja, that was an eye opener to me. Thank you. I'd overlooked that idea of practicing when someone is trying to take us through. Now, is there anybody with that sophisticated board,
Laptop.
maybe laptop, or so that maybe, because guys, I'm seeing something. However much the lecturer is carrying on, you can't grasp what was the last rule? What was it? That which had
Quotient.
what was no, not the quotient. The last one he talked about that has
The chain
divisions
rule.
and something. Yeah, chain rule. Yes, composite rule. Thank you. So if you didn't grasp the constant rule, for sure chances are high that you won't grasp that, because you find that the other basic rules would have to come up and be combined in the rules that come up. That's why you had guys, they were questioning when and at what time, at what point are we applying this rule, and another was asking, should I apply 3 or 4 rules, and which one should I like rely on? You understand, eh? So that's why for me, initially I was proposing that. So I've also resorted on the YouTube, like one of the members suggested yesterday. I went back and just looked for only videos or clips that are talking about the constant rule. That's why I was able to answer number 1 and number 2 and number 3, because I found out they were under that constant rule. But when things got complicated, I had to relax. You understand, guys? So that's why I'm talking after the experience I got yesterday. Guys, Amon, don't laugh at me, man. You might be in the same boat like me. So,
Yeah, in the
yeah,
same
so,
shoe. In the
so,
same shoes.
and we have many ladies here. They are ever silent when the lecturer is
Emmanuel,
teaching.
Emmanuel, I
That's
need
what I was talking
something.
yesterday. We have ready that now nothing anything.
Amon,
I
first
want
keep
ready.
quiet. I need to submit something. Amon,
Someone was so wrong.
you guys first keep
Someone
quiet.
else
I need
has
to
his,
submit
someone has
something.
his problems. Eh?
So we have
guys,
Everybody is
to get a
suggesting.
moderator.
we are not at the same level when it comes to mathematics, but what is very important is to understand the principles. Yeah. And to understand these principles, first of all, we need to define the functions and understand clearly on how we can solve them. Two, the second thing we need to apply is to know which rule. The good thing, the lecturer, he responded to my query where I had a challenge on looking at one number and I can apply more than 2 functions. But his response or feedback, he said, as long as we have the correct answer, you may based on how the question is phrased, you can submit and stop at 1 function. When you look at like number 1, you could submit and stop on the sum rule and you get the right answer, as well as submitting and apply the power rule and get the same answer, as well as applying the constant multiple rule and get the same answer. So I'm of the view that if you want to clearly understand this, we would start from the first rule he told us, or rather, he walked us through, come up with a number, solve it using that rule, and we all agree on how best we can make everyone understand. So as a principle, like we know a constant, it should be equal to 0. That is a principle. So how can we put it in a layman's language and we make everyone understand? Because what I came to understand when the lecturer is doing multiplications, F open brackets, X power, some people completely get lost. Yet each of the numbers, as I've seen them here from 1 to 9, all these numbers, their solutions are within all the rules he has taught us so far. So I'm of the view we can always go by number and identify the right rule to be used in that number. Then we can see one of us who is able to solve walk us through, and then we move forward. I don't know what you think. I submit. I beg to stop there for now. Back to you, moderator Kalipala, I think.
Yeah. Okay, that's quite good. Actually, for me personally, what I think, because for now we have to get ways. How really can we get out of this? Actually, this course that we are taking, it's so applicable to what we are going to do, and it's too essential. So whatever we try out should be in relation to get a way of getting a sophisticated method of discussing these things, so that we try to understand them. Leave alone doing them in a paper because we are chasing, we have to pass, but they are too applicable to us. We have to find a way, since we are basing so online and the institute is basing so online, we have to find a way of discussing these things online way and physical way, but mainly the online way. Either we get, because yesterday Arafat was suggesting we can ask for a board from where? From the university, so that we can express ourselves mathematically. These things can have to be written written down to practice and get the principles, concepts of mathematics. We have to write. We have to practice. There is no way. You can't just read like history. Leave alone communication skills. That is different. But this is a practical subject. So whatever you try out, it has to be practical. So whatever we discuss, let us discuss and find a way how we can express ourselves and practice these things. So that's my view. I don't know if someone can supplement on that.
Edward, I can give you feedback on that because we may fail to get the intelligent board. But if you have a computer with you,
Musaja, let Brian finish, then to come in.
There is another way on how you can write those equations. If you have a computer with you, go to Microsoft Word, go to Insert, and then let me just do it practically here. Microsoft Word, you go to Insert, then you'll see on the extreme right corner, just that the lecturer is still sharing his screen, I would share with you and show you. Then you can go to different equations and insert equations. You can always write them the way he writes them. And maybe we can use that online as we look for a solution where we can get a soft board. I don't know.
The university has soft boards.
Oh, okay, that's fine then.
Again, what you are talking about,
Yeah.
Yes, you can express mathematical equations like how the work looks like, but you can't write. Writing, it needs a pen. Like if you have a notepad, like Samsungs, and there are some laptops that have pens. For that one, it's possible. So expressing this work mathematically, you have to have a pen and to be a bit speedy. The other one, you just have to type, and it's very hard to write answers with that thing. You can do a number even for hours. So we need a pen. You share a screen and write a pen like the lecturers does.
Ideally, how do we get that? I think it's something we can do amongst ourselves.
Which one? Musaja, you had an issue. Express yourself and
No, for me, I was just me.
Hello, I have submission.
Edward.
Hello.
Yes, please.
Yes. Me, I was supporting your answer.
But
your idea, go to that equation. You need a pen. You need a pen to write like how the lecturer was using.
Let Musaja first talk, then Amon, you say something.
What I'm saying, I was also supporting Katria's idea, what he was talking about. That's what I wanted to comment about it.
Okay. So Amon, say something. Amon. Yes.
For me, I was like supporting your opinion.
Emmanuel Mayanja and the ABCJ get ready and others.
When you go to Microsoft Word and you go to insert and go to equation, this mathematics thing need a notepad. You need to get a notepad and get a pen. You write systematically like how the lecturer was using a pen. But when you follow the equation, the computer system equation, you want to write this like how it in this format. You cannot.
That one, you shall try it out. Emmanuel, say something. Emmanuel Mayanja.
Okay, thank you, Edward. Now, this has brought something into my head. How are we going to be presenting our exams and maybe the coursework, since we need to be writing up these things? Has anybody gotten an idea about that?
Yeah.
Hello, can I say something?
Okay. After she switch, they are going to be provided they'll determine.
Musaja, you're too far. I can't hear your words.
Hello, guys. Can I say something?
Rogers, let Musaja finish, then Rogers say something.
Let him talk. Okay, my mic is very
Okay, Rogers, say something.
Now, our overview, like since our lecturer leaves a bit earlier, why don't we always use this time until at let us say at 8, then we discuss through, because here are some people which did like math at an extent level, at a higher level. Especially me, I can help out. And another thing, the other, like I've had a colleague of ours saying, like, how are we going to do? Remember, they told us in our when the meetings we had at first that you can write on a paper, then you scan and submit. I think that one can answer. Yeah.
Are you sure, man? Are you very sure with that?
Yes, he is right. He's right. Actually,
right, then you
that I can't consider that. Yes. So I want you to first go and do research and confirm on it. So,
no, they
said it in the orientation. Yes, even they have to
you guys, if I'm to remember well,
let Monica say something. Monica, say something.
That orientation, what they said, for the first module, you can write in a paper and do what? And submit. Like, is it something of that kind? Yeah. But you have to learn to use your computer, your PC, and do the work from there.
Monica, no, it is not a first module. No, if it was a first module, how to do with what is with sorry, actually with Word and these other kinds of work we did in actually the first
Personally, for me, what I recall, they said you can write on a paper, scan the paper. They have to be scanned paper. Then you upload. If you have multiple files, zip them. That's what they said. Which means if you have like you have done on several papers, you have to scan them, then upload with when they are zipped. I think that's what I recall.
Then for me, I'm trying to say that I'm also far to go and talk on our thing, and the program admin, see what they see, don't ask. So they can't
we shall ask the lecturer about that.
It is better if you ask the lecturer than going
We are confident. So, guys, on Sunday, why don't we talk about Sunday? What time? What time those who manage?
Oh, man. Sunday, don't talk about this Sunday.
Sunday is the Eid.
You try to talk about that
this Sunday.
Sunday. This Sunday, man.
Sunday is Eid.
How about tomorrow?
Tomorrow. Maybe tomorrow. The evening. But I think tomorrow Monica will be somewhere.
You'll be somewhere?
Monica, not me. Monica. Tomorrow she might be somewhere.
So tomorrow, what time could it be? Yes?
Edward.
Yes, please.
Even me tomorrow, I'm traveling for most 8 hours.
So that is Amoni and Musaja, they are out. But what about others? Let us try to be active.
For me,
For me tomorrow I'll be there.